Welcome to Online Algebra 2 class. And today we're going to be going over section 6-6, function operations. So our objective here is to use function notation and to add, subtract, multiply, and divide functions, and then to do something called finding the composite of two functions. And then we'll finish off with a fun thing called a difference quotient. So we can add, subtract, multiply, and divide functions based on how you perform these operations with regular numbers. One big difference, however, is that you must consider the domain of each function when you are putting them together. Okay? So a little bit about, most of this section is going to deal primarily with notation. Okay? So if you look at what this means right here, this means to add two functions together, f plus g of x, we just take whatever is f of x and we add it to whatever is in g of x. Okay? And my notation here is these two functions are in parentheses, both with the common variable x, and it's just a different way to write this. Okay? So subtraction, same thing, subtract the two functions, multiply the two functions together. When we divide, the big thing is that denominators when you divide can't be equal to 0. Okay, so the same is true with function notations. As long as g of x is not equal to 0, we can do this. Okay, the domains of all of these consist of the x values that are in the domains of both f and g. Okay, so if there's anything that's not included in f, it can't be included in the sum. If there's anything that's not included in g, it can't be in the sum. Okay, with the exception of the last one, and that the domain of the quotient function does not contain any x value for which g of x is equal to 0, for whatever makes the denominator equal to 0. All right, let's start with adding. So adding and subtracting functions. Here's f, here's g. Okay, what is f plus g? Let's do this first one first. What is f plus g? So f plus g of x would just be the function for f of x plus the function for g of x. All right, well, what's the function for f of x? It's 4x plus 7 plus the function for g of x, the square root of x plus x. And now I just add the like terms, right? The x's can go together. That gives me 5x plus the square root of x plus 7. Right? Write them in order there. Okay. So nothing terribly fancy here. Okay. The domain of this function is everything that was in here and also in here. So if we think about what limits a function's domain, there's a couple things. That is a limit to the domain. You cannot have 0 underneath a fraction. We do not have any fractions in either one of these, so I don't have to worry about that. Okay, get rid of that. This is a limit to the domain because we're not allowed to have negatives underneath a radical and still have a real number. There is a radical in this function. Okay, so basically, this x right here could be anything. This one could be anything, but this one right here can only be positive. That means that the domain of this function is going to be that x has to be positive, has to be greater than or equal to 0. Writing that in interval notation means that we can have from 0 to infinity. Okay. Again, just because of that radical right there. Right. So let's now do subtraction. So let's do f minus g of x. Okay? And that's simply going to be f of x minus all of g of x. So the most common mistake here would be to write it like this. 4x plus 7 minus x plus radical x plus x. Technically, that's not right because you should have to subtract the whole thing, which means we have to distribute the negative, which means instead of 5x there, we're getting 3x minus the square root of x plus 7. And the domain, again, is that x has to be greater than or equal to 0. Right? What's the limiting factor? That thing. The part of the function underneath the radical cannot be negative. So that means that x has to be greater than or equal to 0. Let's try the guided problems. Okay? So same thing, f plus g of x. F plus g of x. We're just going to take the two functions and add them together. Okay? So we get 2x squared plus x plus 5. And the domain here is all real numbers. Negative infinity to positive infinity. Okay? Why is it all real numbers? Well, there's no radicals. That's a limiting to the domain. And there's no variables in the denominator. That would limit the domain. There's other kind of functions that have a limited domain, but we haven't really talked about them yet, so we're not going to worry about them. And they're not here anyway, right? We have an x squared, and we have an x. We have a parabola and a line. There's no limit to the domain. I can plug anything I want into either one of these and get an answer. All right, next, f minus g of x. Just be careful that you remember that you must subtract the whole second function. And we can put these in parentheses too if you want to. So that's 2x squared minus x minus 11. And again, the domain is all real numbers. Okay? From negative infinity to positive infinity. All right, great. Next, multiplying and dividing. So let's start with f times g of x. Notice that dot right there. It's a solid dot. That is different than what we're going to be doing in the next part, which is going to be kind of a little open like circle right there. Okay, so solid dot means multiplication. So this is f times g of x. All right, and it just means take f of x times g of x. So we're going to take the first function, x squared minus 9, and we're going to multiply it with the second function, x plus 3. Binomial times a binomial, FOIL them together, so we get x to the third plus 3x squared minus 9x minus 27. Okay. So, domain here is there anything, is there any radicals? No. Is there any variables in the denominator? No. So the domain here is all real numbers again. Okay. Now, for the second problem, or the second part, f over g of x, this will probably not, the domain here will probably not be all real numbers because we have something in the denominator. Okay, let's see. So it's x squared minus 9 over x plus 3, f of x over g of x. Okay, then I can factor this top right here, and it factors to x plus 3 times x minus 3 over x plus 3. Now I can cancel that out, so my answer is x minus 3, comma, x is not equal to whatever made this denominator way back in the beginning, whatever made that denominator equal to 0. So x does not equal 3. Okay, and I can write that in interval notation, little fancy, right? That x is every number except for 3. So the domain is from negative infinity to negative 3, and union from 3 to infinity, right? But we can just write this for the domain, that the domain is all real numbers except for 3. We can just put a comma and say that x is not equal to 3. X happens to be one of the excluded values of that function. Let's try the guided problems. All right, multiply, divide. So f times g of x, so this one's going to be kind of a pain. Okay, 3x squared minus 11x minus 4 times 3x plus 1. All right, take it nice and slow. We're going to just FOIL, or we're going to distribute all these together. So that's 9x to the third plus 3x squared minus 33x squared minus 11x minus 12x and minus 4. Cleaning this up, 9x to the third, so that's minus 30x squared, that's those two. 11 and 12 give me a minus 23x minus 4. Domain is, I'm just going to write it like that, all real numbers. Okay, and then f over g of x, well, that's again going to be f of x divided by g of x. So that's 3x squared minus 11x minus 4 over 3x plus 1. Well, odds are that this is going to be able to factor. And I'm going to guess it's probably going to factor into 3x plus 1, which means this has to be an x, and that this has to be a, if this is a plus 1, this would have to be a negative 4. Let's check. 3x squared minus 12 plus 1 minus 4 works, right? So now this cancels, and so my answer is x minus 4, but x is not allowed to be anything that makes the denominator equal to 0. So anything that makes anything in the denominator equal to 0, so it would be negative 1/3. Okay, so that was adding, subtracting, multiplying, and dividing functions. Next, we're going to talk about something called a composite function. So this diagram over here in the green shows what happens when you apply one function g of x after another function f of x. So you take some sort of input, put it into this function, you get an answer. Then you take that answer and you put it into a different function and you get a new answer. Okay, so the output of the first function f becomes the input to the second function. When you do this, it's called a composite. And back to this is the symbol for composite, this little open circle right there. And the way you read it is g of f of x, right? And it kind of looks like that, right? You do the f of x first, then you do the g of x, g of f of x. So we're doing the inside first, and then we're moving to the outside. And this is not commutative. F of g of x does not always equal g of f of x, right? They're going to sometimes not be equal to the same thing. Let's take a look at this. So what is g of f of negative 3? So we're going to start with this one. So we're going to start with f of negative 3. Well, how do you calculate that? You just plug negative 3 into f. Okay, negative 3 minus 5 is negative 8. Then we don't take negative 3 and put it into g, we take negative 8. So we find g of negative 8. And so that's negative 8, all whole thing squared, so we get 64. Okay, so g of f of negative 3 is 64. And guess what the Gotta problem is going to say? What is f of g of negative 3? So now we're going to go backwards. So g of x was equal to x squared, and f of x was equal to x minus 5. So now if I plug -3 in there first, so g of -3 gives me -3 squared, which is 9. Now, this becomes the input. F of 9 gives me 4. Not the same thing. In one answer we got 64, and the other answer we got 4. So very different. Okay. This is composite functions. Plug an answer into, or plug something into the first function, and then use that to get your second answer. Let's try a word problem. So you have a coupon good for $5 off the price of any large pizza. You also get a 10% discount on any pizza if you show your ID. How much more would you pay for a large pizza if the cashier applied your coupon first? Okay, so let's see with this. So let's make x equal the price of the pizza. Okay, so if we're going to use the coupon, right, coupon is a function of price. Right? What does the coupon do? $5 off. So we're going to take the price minus 5. Okay. The discount function does something a little bit different. You get 10% off. So that means you get you have to pay for the pizza, right? And then you subtract off 10%. Right? 0.1 times x. So combining these like terms gives me 0.9x, right? You pay if you're going to take 10% off of a pizza, you have to pay for the other 90% of it. Okay, so let's do two composite functions, and we can actually prove which one is the better deal. So let's do c of d of x, and then let's do d of c of x. So basically, we're starting with the discount first, and then we're putting that function into the outer function. So here's my first function. It goes there. So that's 0.9x minus 5. Okay. So that's all that function is. Okay. Now we're going to go the other way. So now we're going to go this one, and we're going to put it in there. So that one gives me 0.9 times I replace the x with the c function, x minus 5. Now, when we do this, we get 0.9x minus 4.5. Okay. So clearly, no matter what the pizza starts at, you're going to have to pay 50 cents more, 4.50, $5. You're going to have to pay 50 cents more if you do the coupon first. All right. Let's talk a little bit about difference quotients. So for a difference quotient, difference quotients are very interesting. Basically what's happening is we're going to find the instant. Now you don't really have to know what this means. You're just going to have to figure out how to do it. Difference quotients give me instantaneous rate of change on a function, and is the beginnings of finding something called limits and into first derivatives of functions. Okay, so basically we want to evaluate this function at h, but we can't because h is in the denominator, so we're going to find its difference quotient. So here's my function. Find f of a plus h minus f of a all over h. And we don't even have to use the a's. We can change those to x's. It doesn't really matter. So let's take this a little piece by piece. f of a plus h. Function notation says that any, this is a function of x. If I wanted to change it to a function of a plus h, you replace every x with a plus h. And there we go. So that's 2a plus 2h minus 3. F of a just says if this is a function of x, if you want to change it to a function of a, you replace every x with a. So now we're going to take my first function, plus 2h minus 3, minus the whole other function, right, over h. And now, calculating this, 2a minus 2a, those cancel. Minus and minus turns this into a plus, those cancel. So we have 2h over h, which makes my difference quotient simply 2, which happens to be the slope of this line, 2. This is just a constant because the slope of this line never changes. Let's try a little harder one. A parabola. The slope of a parabola is always changing, so my difference quotient is going to have a variable in it. Let's break this down again. So I replace every x with a plus h. So that's 4 times a plus h squared minus 1. I'm going to have to work this out. Do not multiply first. Exponents come first. So that's 4 times a squared plus 2ah plus h squared minus 1, which is 4a squared plus 8ah plus 4h squared. A lot of weird letters running around here, but that's okay. F of a is simply going to replace the x with the a squared, which is, again, this formula you might see it like this sometimes, so that way you don't even have to do this step and there's x's in it. Which is probably the way I would give it to you. So 4a squared plus 8ah plus 4h squared minus 1. Subtract off this whole function, so we have 4a squared minus 1 all over h. Start to simplify this. We get 4a squared minus 4a squared. Those cancel. Minus a minus turns into a plus. So negative 1 plus 1. Those cancel. So we have 8ah plus 4h squared over h. I now, on the top, have a common factor. I have a common factor of 4h, but let's just factor out an h because that's the only thing that's going to cancel. 8ah plus, or sorry, I factored out the h, 8a plus 4h over the h, which can then divide out. So my answer is 8a plus 4h. And that is the difference quotient of this function. And what really is what the interesting part is what happens when h is now 0, right? If I had plugged a 0 into this function right here, it would have been undefined. But now if I plug the 0 into this function, I get this answer right there, which happens to be the first derivative of this function, which is the beginnings of calculus. Okay? So hopefully we understood the basics there, in that to add, subtract, multiply, and divide functions, we combine them together. This is a composite, which means that we take g and we plug it into f. So we take this whole function and we would replace x with that. So f of g of x would be 3 times x squared plus 1 minus 2, right? The variable x gets replaced by the function g. And then if it was the other way, right, if it was g of f of x for number 3, we would just go backwards. We would take this whole thing and we would plug it into x squared. So it would be 3x minus 2 squared plus 1. You just replace the letter X, everything else stays the same. You replace the letter X with the function. And then we would simplify both of these. Okay? And that was 6-6, function operations.